Hi friend, I hope you're doing well. So as you can see, I have already uploaded the image and I just wanted to tell you that working on immunohistochemistry and working on hematoxin eosin staining, they are two different things. First, and in immunohistochemistry, you can find the things very specifically. For example, you have used the DAB. Now, using this DAB, you'll be able to figure out how many tumor cells you can find, how many CD3 cells you can find in this. But when it comes to the case of HNE, it's a little difficult because all of them looks very same. The tumor cells, the what's it called, CD3 plus, all the tumor infiltrating lymphocytes, they all look very much similar. You don't have to worry. I'll work on the hematoxin eosin staining. I thought I have some time, so I'll figure out. I'll help you out with the immunohistochemistry first, and then if I get my time, I'll help you to figure out you know, the tills in the HNE. And you if you want some separate differentiation between classification between the tumors and the stromal, I can also help you with that also. But right now, let's focus on the cell detection part. Okay. So the first thing you have to do is you have to annotate it first, and then you have to analyze the first look into the staining part also. Uh, yeah. So you can see when you plus 2, 3, 4, or you can just press 2, you can find the staining, different type of stains have been used. You can go to the tools, view, brightness and contrast. Yeah, there's staining which is called, but I don't think you must have to use that. So you go to the analyze cell detection. First, you detect the cell, and I would love you to work on the parameters, which is like keeping the threshold little less so that it can detect all the cells. After detecting it, you can see it has detected all the cells, right? And these are the noise, so automatically it won't. But if you feel no, it's not noise, no, it is cell, then yeah, you can reduce the threshold and you can see that still it's not detected. But even if you reduce the threshold, there's a possibility it can detect some other thing. So let's assume that this is noise, okay, for the time. Okay. Let's keep it 0.09 because that's the proper one. Now, as you can see, it has detected all the cells, and now you have to go to the cell detection again, and you can work on the positive cell detection. So keep the parameters same and try to run it again. Okay, now you can see. So these blues are called negative and these are called positive or the CD3 plus cells. And but you can see here that these are all positive has been detected. And it's little incorrect, but it's okay, I would say. So you can little bit increase the threshold here to have an accuracy. So you can see it's like it is detecting it accurately. If not, you can go for 0.0 threshold to 0.2. But you can see that some of them aren't detected. So keep the threshold 0.1 and you can see that it has been detected. And but I would say that it differs from each cell, each image to each image. So you have to look into it. You have to look into the threshold part. As I told you before, you have to work on it. And after working on it, you can go to the measure. So the annotation measures. Sorry, not TN, annotation measures. And you can see here that this part alone has this number of detections. 279 is the number of negative, which is the tumor cells, and positive is 394, which makes sense because there are a lot of DAB than the tumor cells. You can work on that. And afterwards, when you're doing some, when you are working on the complete database or complete image, you can you can standardize it. I would say you can standardize using ANOVA or t-test or anything like that, and you can work on this. So the number of negative is the tumor cells, and number of positive is uh, this one. What's it called? Uh, CD3 cells. Now coming here, you can find here that in these sites there's no proper. CD3 cells, but here you can find a lot. So like that, the same way which I told you before, just annotate it. If you find it, if you find it difficult, you can go big. But I would suggest you can use this method, the watershed method. It's called the watershed method, where it can completely do this, and from there you can detect it. Okay. So this is how it is done. So this is small part which I have given. And after detecting each circle, you can go to the TMA. You can see all the annotation measures, copy them in an Excel sheet, and you can start analyzing them. So that's one thing you can do. For HNE stainings, I'll help you out a little later as I'm traveling before it requires a lot of time. There are some methods which can be used using Python and different codings also, which I'm working on it. That's my CodeCell. That is the new startup which I've created, CodeCell.ai, where I'm working on different AI model, different LLM models, different AI models where it will help you to detect it properly. There are some tools and tools are there, which where we can standardize it. So you can use this QPath for time, and afterwards, when I get time, I'll let you know about this. As of now, this is it. Let me know if you have any more doubts in this cell detection. Thank you.